Good morning. Hi, everyone. I'm Idan, and I work in GitHub's Office of the CTO. Our mission is to explore the future of software development. We figure out how to make it safer, faster, easier, and more accessible. When I was thinking about how to introduce our speaker for today, I realized that our mission is missing something that Simon has been doing for most of his career. Writing software that's impactful, software that enables others to use software, lowering the cost of entry for everyone. Most often associated with the creation of the Django web framework, Simon has been influencing journalism and journalists throughout his career. Django itself was born out of the needs of the newsroom at the Lawrence Journal World. And later on at The Guardian, he was involved in one of the first large-scale crowdsourced journalism campaigns, building tools to annotate a gigantic cache of government documents, bringing sunlight to what would otherwise be impenetrable. And more recently, he was a JSK Fellow at Stanford working on Dataset, a Swiss Army knife for querying and sharing data that is aimed squarely at journalists, scientists, and anyone who needs to explore and publish data. It's been my experience that whatever Simon is chasing ends up being accepted best practice for everyone in about 2 years. So I'm incredibly excited to hear about his latest efforts to grapple with our growing mountain of personal data. If you have any questions, Simon will shortly be sharing a Google Doc URL where they'll be collected for Q&A at the end. Simon, thank you so much for joining us.
Oh, thank you. Thank you, Idan. Hello, everyone. So yeah, my name's Simon Willison, and I am going to be talking today about personal data warehouses. So what they are, why you want one, how to build one, and some of the kind of crazy things you can do with them once you've got one running. And I'm just going to share my screen.
You're good.
I am good. My screen is visible. Fantastic. Okay, so as Idan mentioned, I'll be taking questions for this in a Google Doc. So there's a URL at the bottom of the screen, bit.ly/octo-simonw. If you go there, you'll be dropped into this document and you can collect questions in this section at the bottom. And also, please feel free to add in notes and things as we go along as well. Let's use this as a collaborative space during the talk. So I'm going to start with a demo. And for the demo, I'm going to use Cleo. This is Cleo. Cleo is my dog. And as you can tell, she is a proud resident of San Francisco. She won first prize in a costume competition a couple of years ago, dressed here as the Golden Gate Bridge. But the question I want to answer is, how much of a San Francisco hipster is Cleo? And I can do that using my data warehouse. So I use Foursquare Swarm, and I've used it for nearly a decade now, and I check in at different places that I go. So I've exported all of my data out of Swarm on a regular basis into a database table, so I can see a map of 10 years worth of my check-ins. But much more interestingly, every time I check in with Cleo, I use the wolf emoji in the shout, which is the check-in message, which means I can run a query where I can say, show me all of the check-ins where the shout contains that wolf emoji. And if I do that, this will trim all of my check-ins down to basically a map of Cleo's favorite places. This is 280 places that Cleo has checked into. But I want to know sort of what kind of stuff is she into. So I'm going to facet by venue category. Faceting is essentially a sort of group by count operation that shows you a count of the number of different unique values in a column. And so I can see that Cleo has checked into a park 57 times, a dog run 32 times, but a coffee shop 19 times. So in our exploration of her San Francisco hipsterness, let's take a look at a map of coffee shops that Cleo has checked into. She's got 19 check-ins. They should just, here we go, there they all are. And I can facet once again by venue name.
Simon, apologies for interrupting. We're not seeing your screen update.
Well, that's strange.
We are still seeing your title screen, so maybe try unsharing and resharing your screen.
Okay. How do I do which button? How about now? Can you see anything now?
Success.
And you can see a map of Cleo's check-ins, right?
Yes.
Fantastic. My apologies for that. So very briefly, I started with all of these check-ins. I filtered them down to just the ones with the wolf emoji. And then I filtered those down to just the ones where the venue category was coffee shop. Now I'm seeing a map of coffee shops that Cleo, my dog, likes to visit. And if I facet by venue name, I can see that she's been to Blue Bottle 11 times, Ritual Roasters 3 times, but she has occasionally sort of been unable to avoid the temptation of Starbucks. So obviously this is a really useful thing. Being able to do a map of all of the coffee shops that your dog likes is hopefully reason enough to build yourself to get interested in analyzing your own personal data. But I'm going to take a step back from the demo and talk about the software, talk about how this system actually works. The key piece of software here is this web application I'm running called Dataset. And Dataset is a project I'm working on for almost exactly 3 years now. In fact, the 3-year anniversary of its initial launch is tomorrow. So this is almost Dataset's birthday. And the idea with Dataset is to build an application that makes it as easy and cheap and inexpensive as possible to explore data in all sorts of different shapes and sizes. I'll show you one more demo of Dataset just to give an idea of what it can be done, of how it can apply to journalism. Well, actually, I'll talk about where this idea came from. So I was working at The Guardian nearly 10 years ago, and one of the things I realized when I joined The Guardian is that The Guardian had enormous quantities of really interesting data already because it's a newspaper. And anytime a newspaper publishes a chart or a map or any kind of visualization in the paper, somebody had to go and dig up the numbers for that visualization. And there was a journalist there called Simon Rogers, who was an absolute wizard at tracking down data. He could ask him for any fact in the world and he'd know who to call and which government sources to bother to get that data back out again. And all of that data lived in Excel spreadsheets on his desktop computer. So we conspired and thought, okay, is there a way that we can publish this data as well as the stories, sort of publish the numbers behind the stories? And we started this thing called the data blog. And the idea was, anytime The Guardian puts out a story with numbers in, we'll publish the numbers as well. The challenge we had is, how do we publish those numbers? And we ended up going for the sort of cheapest and most easy to get going solution, which was Google Sheets. So The Guardian would publish a Google Sheet with US public debt by day, or whatever the number was behind the stories at the time. And despite being a pretty low-tech way of doing things, this worked extremely well. We had a community of people who would they had a Flickr group where they'd publish their own visualizations of numbers from The Guardian. And it's since become pretty common for newspapers to publish that underlying data, which I think is a really, really exciting trend. But I was always frustrated by this because I felt like there really should be something better than Google Sheets for publishing data, something more flexible and essentially more open that we could use to get this data out into the world. So fast forward 7 years, in 2017, I was looking at serverless hosting, this new style of hosting provider, and thinking, okay, what are the things that I can do with this that I couldn't have done previously? It's a question I always ask myself with new technologies. Okay, what does this let me build that wasn't possible before? And there are lots of definitions of serverless out there. My personal favorite is this idea of scale to zero. If your project isn't getting any traffic, you're not spending any money on it. And as somebody who loves creating crazy little side projects, but this is absolute gold for me, because it means I can build a crazy thing, put it online, and not end up paying $5 or $10 a month for the rest of my life for it to stay visible. So these serverless hosts, they scale to zero. They're very inexpensive generally. But the catch that you find with a lot of these things like Vercel, which used to be called Zeit now, or Google Cloud Run, or Heroku, is that if you want a database, it tends to cost extra. Because databases, things that are storing data that's changing over time, are still a lot more expensive to run and operate and scale up. One of the beautiful things about serverless hosting is, since it's just code, you can scale it by just running more copies of it. So you essentially get infinite scale, provided you're not worrying about a database. This made me think, well, okay, so I'm not allowed a database on these things, but essentially I get to give them a Docker container and they run that container in the cloud. What if I put my data in the Docker container? Like, what if I'm dealing with databases that don't have updates? They're not changing, but they're still data that I want to publish. And I realized that that was the exact problem that we'd been wanting to solve at The Guardian. How do you publish data online in a way that's as flexible and inexpensive as possible? And so that was the initial impetus for Dataset was, if I bundle the data and the code together in a single, usually in a Docker container, and deploy that to the internet, can I take advantage of serverless hosting and the fact that it's almost free for the size of project I was caring about, but use it to share these interesting data sets with the world. So the first couple of years on Dataset was spent solving exactly that problem. I'll show you another demo. This is an organization called the World Resources Institute, and they publish a global database of power plants. And they publish this as CSV files on GitHub. And this is a pattern I'm seeing increasingly these days. There are so many interesting point of truth data sources that use GitHub as their primary way of distributing the data. And the CSV file is great, but we can do better than that. So I've got a script which runs, I think, a couple of times a day, checks for updates to this. And if there are updates, it publishes it using Dataset. So this right here is the contents of that CSV file that is published by this organization. Only once I've got it in Dataset, I can start doing more interesting things with it. Dataset supports plugins. You've already seen this plugin for my dog's map of coffee shops. This is a plugin called Dataset Cluster Map. And what it does is looks for tables with latitude and longitude columns, and if it finds one, it draws them on a map. So straight away, looking at this data, you notice, oh, there's a couple of power plants down here in Antarctica. And yeah, this is McMurdo Station, which has a 6.6 megawatts oil generator, and Ross Island has oh, look at this, I didn't know that. There's a wind farm down in Antarctica knocking out 1 megawatts of electricity. But this is also an illustration of faceting. So if I want to see a map of just the nuclear power plants there's 198 nuclear power plants in the world, and I just want to see the 19 that are in France, here it is. This is a slice and dice of nuclear power plants in France. A couple of really important features that I should illustrate. Firstly, everything that you can see in Dataset, you can get out as raw data. So if I click JSON right here, this is a JSON document of nuclear power plants in France. It's that filtered data. I can also get it back as CSV if I want to export it into Excel or other CSV compatible software. Even more fun, if I click View and Edit SQL, I get the actual SQL query that was used to generate this page, which I can edit. So I can say, you know what, I just want the capacity, the latitude, longitude, and the primary fuel. And if I trim this down here and then re-execute the query, there we go. This is just giving me back those 4 columns, which I can then get back as JSON. So this, in most web applications, would be seen as a terrifying security hole, because this is SQL injection, except as a core feature of the framework. The reason it's not a problem here is, firstly, we're dealing with a read-only database. Updates and inserts and such like just aren't allowed. The file is, the database is immutable. I've also got a time limit set in here. So if the query takes more than a second to run, it'll return with an error. And also, the whole point of this system is to publish data. There is nothing in this database that isn't safe to be exposed to the world. There are no password hashes or any private data at all. But this also means that we've got a JSON API that lets JavaScript execute SQL queries. Like, I can construct this URL up here in JavaScript, add .json as the extension, and get back the JSON results of any SQL query, which I initially thought was just kind of amusing, but I've actually found as a prototyping tool, this is really powerful. I can build prototypes in JavaScript where I literally embed SQL statements into my JavaScript code. So that's a sort of example of the kind of stuff that you can do with Dataset. It's worth talking about what the secret sauce under the hood is. And the secret sauce behind all of this is this incredible database called SQLite. Everyone on this call uses SQLite every day, even if you don't realize it, because it is it calls itself the most used database engine in the world. It's designed to run on devices. So I've got a SQLite database in my Apple Watch that tracks my steps. Most of the apps on my iPhone are using SQLite. Desktop apps use it. It's absolutely everywhere. And it's fast, it's self-contained, It's very reliable, extremely well tested. But my favorite attribute of SQLite is that the database itself is a single file on disk. It's a .db file. You compare this to MySQL or Postgres, where you've got a server with all sorts of crazy directory structures going on. No, a SQLite database is one file, which means you can back it up, you can send it to people. It's a really easy thing to work with. And for my purposes, it's easy to package up in a Docker container. So all of these deployed data sets are a database file that I've created. I stick it in the container with the application code, and I put that thing online. So I'm going to show another demo, which I think is particularly relevant to thinking about how GitHub fits into all of this. Last year, you may remember that PG&E, the electricity company that covers most of California, had a whole bunch of scheduled outages to deal with risks of wildfires. They turned off power to huge quantities of California. And I got really lucky with this because 6 months before they started doing that, I'd started quietly scraping their outage map and dumping the results into a Git repository. So this right here is a GitHub repo with 34,000 commits tracking the history of outages that PG&E published on their outage map. You can see that 2 minutes ago, they added 35 new outages, they removed 2 outages, and they updated the details on 23 of them. This is a technique that I recently gave a name to. I'm calling it Git scraping. And the idea with Git scraping is, here we go, is that you can take any data endpoint on the web, which is a sort of point in time snapshot, like this is the power outages right now. And if you repeatedly commit it to a Git repository, you get a commit log that tells the story of the history of that particular thing. This technique really stood out just last week when while the election results were coming in. You may have seen this website. This is the New York Times 2020 election scraper. So what this page does is it scrapes the New York Times current list of votes that have come in, but because it's keeping a history of them in a Git repository, it can show you how they've changed. So it'll show you that 39 minutes ago, there was a change of 140 votes in the state of Nevada. And it's absolutely worth taking a look at the code for this. It's a GitHub Actions script that runs on a schedule, and then it's a repo where they've been tracking the history of this over time, plus some really clever Python code to build that web page and figure out the differences and all of that kind of stuff. But this technique, I think, is super useful in working in journalism for tracking things, but also for any time that you want to keep track of how something changes over time. Thanks to GitHub scheduled actions, setting one of these up is really, really simple. So I've got a demo. I'm going to do a little bit of live coding just to show you how this kind of stuff works. I'm going to use the Cal Fire website. So this is the official state of California fire website. And anytime I see a map like this, my first instinct is to open up the developer tools and see if I can figure out how it actually works. So I'm going to hit Inspect Element. I'm going to open up the Network tab, refresh the page. And then a really fun trick with these is to filter by XHR requests and then order by size. Because when you do that, inevitably, the things at the top of the list are the actual data for that page. This thing right here looks interesting. I'm going to open this in a new tab. This appears to be a JSON file telling me about all of the current fire incidents in the state of California. And it is that, so I actually set up a scraper for this a while ago, which grabs which commits this to a Git repository. But I'm going to take this a step further and turn this into a Dataset instance. Looking at this, the all year instance key appears to be the most interesting. It's got 260 things in it. Each of these is a fire that occurred this year. So I'm going to curl this. That gives me back the JSON. I'm just interested in all incidents, so I'm going to pipe this through the JQ command, JQ dot, what was that thing called? Dot all year incidents. There we go. That's a list of incidents this year. Now I'm going to pipe this into a tool I've been building called SQLite Utils, which is a suite of utilities for manipulating these SQLite databases. In this case, I'm going to use the insert command, insert it into a fires.db. I'm going to call it incidents. Actually, I'll call it CA fires. And I'm going to read from standard in. So I do that, and now I've got this CA fires.db file. So I can open that in Dataset, running the Dataset command. And here it is. This right now, this is a brand new database that we just created using data from this API. And you can see there are 261 rows. You straight away see that one of them has a dodgy piece of data entry and that the latitude and longitude have been set to the same value, but 258 of them are in the right kind of place. And I can also do things like I can facet by county. So I can see which counties this year had the most fires. Riverside had 21. But I'm going to take this a step further, and I'm going to put this on the internet using a command called Dataset Publish. So with Dataset Publish, I can select the hosting provider I want to use. I'm going to use Vercel because I happen to know it deploys really quickly. I'm going to say Database Publish Vercel cafires.db, and I'm going to give it a project called cafires. And I'm also going to tell it that I want it to install that Dataset cluster map plugin. So this will then take that cafires.db, it'll bundle it up with the dataset code itself. It'll push it out to Vercel. It gives me this URL so I can watch what it's doing right here. This will probably take about 30 seconds to build that data. Oh, it's queued, so maybe I'm in a queue behind a few other things. I'll come back to this in a few seconds. But the idea here is to make it to have as few steps as possible between finding some interesting data, turning it into a SQLite database such that you can query it and use Dataset on top of it, and then stick it online with a URL so that other people can start using that as well. Oh, here we go. It's installing required dependencies, uploading build outputs, and it's done. And now when I click visit, this right here is that database that I just created, but it's now available online for anyone to view it, query it, interact with it, and even export JSON back out and build their own API integrations on top of this data. But what has this got to do with personal data warehouses? So I've given you a whistle-stop tour of Dataset for the purposes of publishing data and sort of doing serious journalism. And then last year, I read this essay. This is an essay by Stephen Wolfram, and the title is wonderful. It's called Seeking the Productive Life, Some Details of My Personal Infrastructure. The main feature of this essay is how long it is. If you look at this little scroll bar, it's this incredible exploration of 40 years worth of productivity hacks that Stephen Wolfram has applied in order to become a CEO of a 1,000-person company who works remotely. He's based 1,000 miles away from the office, which I guess we all are now with COVID, but he was ahead of us in that one. But he's put an enormous amount of work into optimizing every aspect of his professional and personal life. Now, he has a standing desk, but then his heart rate monitor showed him that his heart rate's better when he walks around outside. So he built himself a little laptop tray so he could go walking in the woods. And he's scanned every document from when he was 11 years old. He's got a green screen in his basement so he can give talks from home. All of this amazing stuff. And I was reading through this thinking, wow, this is completely crazy. But there was one thing in here that really caught my eye. He talked about how he has a thing that he calls a meta searcher. It's a search box on his personal homepage that can search across all of his emails and journals and people he knows and files on his machines, everything he's ever done, all brought together in one place. And I thought to myself, you know, I really want that. I love this idea of like a personal portal onto my own stuff. And so because it was inspired by Stephen Wolfram, but I was planning on building a much less sort of alpha version of what Stephen Wolfram had built, I decided to call it Dog Sheep. He's Stephen Wolfram. My thing is called Dog Sheep. And so I've been building this over the past year. And this is my personal data warehouse. This is a tool which pulls in as much data as I can find about myself from as many different sources and gives me an interface that lets me explore it and run queries against it. And so I've got data in here from Twitter, from Apple Watch HealthKit. I've got GitHub data, Swarm check-ins, my photos. I've got a copy of my genome. There's a whole bunch of different stuff that I'm running in here. And I'll show you a couple of demos. Here's another demo with Cleo. So Cleo has a Twitter account. And every time she goes to the vet, she posts a selfie and she says how much she weighs because she gets weighed at the vet. And so what I'm doing here is I've got a SQL query which finds every tweet where she mentions her weight, uses a regular expression to pull out her weight in pounds, and then I can use a charting plugin to draw a chart of her weight over time. So this is Cleo's weight over time as reported by her personal selfies on Twitter. It's clearly another super useful thing to be able to do. I did 23andMe a few years ago, so I've got a copy of my genome in dog sheep, and I figured out a SQL query that can tell me what color my eyes are. Apparently my eyes are blue 99% of the time because this RSID is a GG genotype. Again, crazy useful. I mentioned Apple Health Kit. So I use the Apple Watch. The amount of data the Apple Watch tracks about you is absolutely astonishing. And something I really like about Apple's approach to this is that they don't stick this on the cloud for you. They keep it on your watch and on your phone. Turns out there's an export button in the health app on the phone that you can use to export a zip file full of XML with all of this stuff in. So I wrote a script which converts that zip file of XML into a SQLite database. And now I've got things like my basal energy burned, my body fat percentage reported by my scales, flights of stairs that I've climbed, my heart rate, my mindful sessions, although I've only done one mindful session because apparently I'm not very mindful. But the really fun stuff is anytime you do an outdoor workout and track it on the Apple Watch, turns out it records your latitude and longitude every few seconds. And you can get that data back out again. So when I ran the San Francisco half marathon, this was 3 years ago, I now have a map of the exact route that I took. And again, it's available as CSV, it's available as JSON. This is a really amazing way of extracting and exploring your own personal data. Every time I go on a walk now, I track it as an outdoor walk on my watch, just so I can get that GPS data back out again later. A couple of other things. This is a super useful thing for people who use GitHub a lot. I've pulled in all of my GitHub activity from, and that's commits I've made to projects, issues, issue comments, releases, everything that I can get out of the GitHub API for my project. And it means I can do things like view all of my commits to every project I have on GitHub. I can facet and say, okay, show me the 61 commits I made to Dataset cluster map. I can search them. So if I search for PyTest, it'll show me all of my commits that mentioned PyTest in the commit message. And again, because I can build custom SQL queries here, I can actually build essentially little applications that are defined as SQL queries, which I then bookmark. So if I want, so I've got a bookmark which can show me issues that I haven't replied to yet based on a sort of SQL subquery. I've got, I use SQL views as well. Here are recent releases across all of my projects, which is very useful when once a week I'm trying to write up my week notes on what I've been working on. A really fun one, I use Apple Photos. And again, Apple Photos, like HealthKit, it does a huge amount of work on your own devices, including, it turns out, running machine learning analysis against your photographs directly on your device. Apple download a machine learning model to your phone, and they run that against photographs that you take. And it's all stored in SQLite. There's a SQLite database for the Apple Photos app, which once you get access to it, you can pull all sorts of interesting things out of it. So here are photos that I've taken, and you've got location information and that kind of stuff as well. But if you pull out the machine learning labels, you can do things like run SQL queries that show you photographs you've taken of pelicans. So this is a SQL query that's finding everything where one of the machine learning labels was pelican. And you can see that Apple Photos does a pretty great job of identifying pelicans. But the really fun thing I found digging through their database is it turns out they calculate scores. So there are columns in Apple Photos for things like Z overall aesthetic score, Z highlight visibility score, harmonious color score. There's even one for pleasant camera tilt score. And they don't expose this in the applications, but it's there in the data. So this right here isn't just photos of pelicans I've taken. This is ordered by the aesthetic score. So this is Apple's algorithmically selected best photographs I've taken of a pelican, which is a pretty useful thing to be able to do. If you want to know more about this, there are links in the notes. I have a entry in my blog where I talk about using SQL to find my best photograph of a pelican. And then a few weeks ago, I finally got around to building the search engine. I'm calling this dog sheep beta because Stephen Wolfram has a search engine called Wolfram Alpha. And actually, the pun for this, I came up with this pun a year ago, and I enjoyed the pun so much, I committed to building the software. So this is essentially 12 months of pun-driven development at this point. But this lets me search across my tweets, bookmarks on my blog, Git commits, blog entries, my comments on Hacker News, all of this different stuff all in one place. And I actually used this the other day. I was trying to answer the question, when did I last eat a ice cream that was shaped like a fish? And I remembered I did it in Cupertino. If I search for Cupertino, this shows me tweets about Cupertino. Oh, hold on. Oh, that's because I've got the is public filter on. It also shows me my photographs that were labeled in Cupertino. And so I can scroll through these, and there we go. This is the last time I had a ice cream shaped like a waffle, was the 5th of December 2019. But this hopefully gives you an idea for the kind of power you get once you get if you can get all of your data into one place, especially into like a database that you control, the things that you can build on top of it are essentially limitless. And I feel like lots of nerdy people have tried doing this stuff in the past. The catch is always, okay, so you've accumulated all of this data. How can you build stuff on top of it? And I think being able to, having it in these SQLite databases with a relatively simple web interface on top, that feels to me like the missing piece. That's the thing that you need in order to be able to slice and dice your data without having to write lots of additional software on top of that raw interface. Oh, there we go. That's the Vercel. The Vercel application has deployed here and is running here. So a couple of last thoughts. Firstly, one of the big helpers in all of this is this European law, the GDPR, which came into effect a couple of years ago. And essentially, it means that you have a right to the data that companies hold about you. Most of the big internet companies, their answer to this has been to add export options. So if you dig around in pretty much any large site that you use, Facebook or LinkedIn or Twitter, somewhere buried in the settings, there'll be an export button. And if you click that export button, they'll probably email you a link to a 2 GB zip file full of XML or JSON or whatever, which isn't that useful on the surface. But if you build tools to turn that into, say, a SQLite database, you can suddenly start deriving all kinds of useful things about it. The GDPR, actually, it turns out you can normally you can contact these companies directly and make I think it's called a subject information request. You can request additional data, which they will send you as well, but they're trying to keep their customer support costs down as much as possible by giving you that self-service export. So a lot of this stuff becomes increasingly easy over time as more companies build the export tools that we need to build this. And then the other challenge is, how do we democratize access to this stuff? So everything I've shown you, it's all open source. You're welcome to go and run it yourself, but you will have to set up cron jobs, run a server somewhere, figure out how to secure it, all of that kind of stuff. And it's a lot of work. But it feels like this is something that regular non-super nerd humans should have access to. I've got a few thoughts about that. I think expecting regular human beings to run a web server somewhere is pretty terrifying, right? Running a web server is not easy. I have been looking at WireGuard and Tailscale as sort of personal VPN options, which do make it a little bit easier to secure access between your devices. But this is still like a super power user level type of thing. I've shown this demo to a few people who said, oh, wow, you could totally like do this as a hosted service. I would hate that, right? Taking responsibility for people's super private personal data is a terrible risk, and it's also a terrible business model. You're not going to make a great deal of money out of people doing that for them. So I think the best options for this stuff are applications that people run on their own devices. Imagine a desktop application, or even better, a mobile application that people could run, which could ingest their data and give them the ability to explore it in this way. And so I've been looking at how Dataset itself could run on mobile devices, with an interface that lets you integrate with different data sources. I think it's it's a lot. Again, it's a lot of work. I'm hoping it's not top of my priority list right now, so I'm hoping I can inspire other people to start thinking about how to solve these problems. But I do think there's something very, very powerful about giving people this sort of super flexible control and access to the data that exists about them around the world. My call to action, please try this yourself. Everything I've shown you today is open source. If you go to dataset.io, that's details about Dataset. I have github.com/dogsheep is the organization that's sits on top of all of the Dogsheep tools. These are things like GitHub to SQLite and HealthKit to SQLite and Swarm to SQLite. You may notice a naming convention here. These are tools that turn that data into SQLite so that you can use it in that way. And if you check out my blog, simonwillison.net, or follow me on Twitter, this is something I talk about a lot there as well. So I'm going to switch over to the Google Doc and see if we have questions that I should answer. What happened there? Hang on. bit.ly.com/OCTO SIMONW. Aha. Okay. I'll skip the first two because I seed it with those just in case. Will there be a Dataset hosted service I can pay for? Yes, there will, but it's not for I'm not creating it for personal use. I mean, you could use it personally, but the idea that I have around the hosted service is I want to help journalists and newsrooms and people who need essentially a version of Dogsheep, but for their organization, for their company. So I've been building out a cloud-hosted version of Dataset, partly because I put so much work into building these things, and then I shouted them to journalists, and they're like, "So I have to install this where?" And I feel like I'm not able to unlock the value of the software I've built if I have to talk people through installing Python 3 and getting an environment set up and running a server and all of that kind of junk. So I am building a sort of aimed at companies hosted version of Dataset at the moment. How do you sync your data from your phone or watch to the data warehouse? It is a manual process. You know what? I can actually do a very quick demo to show you how that works. I found out recently you can run QuickTime, and you can tell QuickTime that you want to do a new recording. Oh, except, there we go. So you can now see you can use QuickTime to mirror your iPhone to your desktop. So I'm going to open up the Apple Health app, and then in the Health app there is a Export All Health Data button. You click that, and it churns away for about 5 minutes, but then it gives you a literal zip file that you can airdrop onto your computer. So I do that. I airdrop onto my computer, and then I run my HealthKit to SQLite script there. Most of the sources in Dogsheep, thankfully, are automated. They have APIs that I can hit from a cron job. The HealthKit data is the best example of data that I can't do that with. I have to, about once a month, I'll run the export, I'll run the script, and then I SSH up the database. When accessing GitHub data, do you run queries against the API? Right. So one of the core philosophies I have around this is I just want all of the data, right? Because if you can give me an API with like search filters and all kinds of different things, and I'll still think of something that I can't do with your API. What I'll do instead is I will try and find an endpoint that I can paginate through to get everything. I'll pull down all of the data, stick it in a local SQLite database, and run queries against it that way. So my biggest ask of anyone who has an API is give me a endpoint that gives me everything, and then give me an endpoint that gives me everything that's changed in the last, say, 2 hours. And so things like Swarm, I run it, I actually, you know what, I can show you the Swarm thing. So I have a command called Swarm to SQLite, and I can say swarm.db, and I can say since equals 2w, and this will then fetch all of my check-ins for the past 2 weeks. Oh, that's interesting. I wonder why that happened. All right, the problems with live demos. Something has broken about this, or maybe it hasn't. So I have got that. There we go. So I've got my Swarm database, and if I open that up in Dataset, I'm now looking at just 2 weeks worth of check-ins. But yeah, so a lot of the endpoints I like are the ones where you can say, give me everything that's changed recently, because then you can hit them from a cron job as often as you want to. Have you explored doing this as a single page app? So it's possible to display as a static site. Well, I'm a proper old-fashioned server-side engineer, so I think you could potentially do this as a static app by getting all of that data into a SQLite database, and then there's a thing called SQL.js, which is SQLite itself compiled into JavaScript using WebAssembly and such like. And there's actually there's an observable notebook that does exactly that. So this right here is an example of an observable notebook that in JavaScript is pulling in a SQLite database and then querying it from SQL. So you can do that kind of thing. You'd have to rebuild all of Dataset because Dataset is a designed as a server-side application. But the other thing that's good is, I wonder if I've got sftrees.com working. Maybe it's sf-trees. Because everything that Dataset does is exposed as a JSON API, you can build JavaScript applications that query that API. This is an example I built, which is a search engine for trees in San Francisco. And this is it's a single-page JavaScript app. If you watch what it's actually doing, let's search for beech tree or palm trees. What it's doing is it's doing a JSON request to a Dataset instance and running a SQL query. So literally, somewhere in here we go. There is a SQL query embedded in the JavaScript. Dataset supports CORS headers. So this little JavaScript application right here is static HTML and JavaScript that's pulling from a Dataset API. And I recently, well, this year I built a Dataset plugin that lets you do GraphQL queries as well. So if you go and look at this demo here, there is a GraphQL API to, in this case, all of my the GitHub data that I pulled in. So if you like using GraphQL, Dataset can act as a GraphQL backend for your apps as well. Do I have any cron job examples of scrapers that I can share? Yes. What I will do is cron job examples of scrapers. I will share those in that document later on. I'll copy and paste them over from my private repository. And then what possibilities of data entry tools do the writable canned queries open up? That's a very interesting question. So writable canned queries are a feature that I added in Dataset 0.48, maybe, about 6 months ago. And this was basically, this is part of moving Dataset from this thing that just works with read-only data to a thing that can write to SQLite databases too. So you can create essentially you can configure Dataset and say, I want an update query, an insert query, which sits on a page, and people can then use that to execute controlled writes against the database. Right? We don't want people executing any SQL that they like, but if you sort of allow list SQL queries that you know are safe, then you can build them that way. I've not really explored those as much as I want to yet. One of the ideas there is to make it super easy for people to essentially create forms, right? Create forms that submit data into a database. I think it's still very early days with that feature though. So I'm keen on exploring that for things like building crowdsourcing applications, accepting feedback from people, like blog comments. There's lots of things like that you could build, but it's not really been an emphasis of the projects I've been working on. Okay, for the local version, we had one line push to deploy. How do you handle updates? That is so that was when I ran Dataset publish. Yep, with all of these hosting providers, you literally just publish it, you deploy a new version. Like Vercel was designed to allow people, they actually had to cut down the number of deploys people do. They now only allow, I think, 160 deploys a month because people like me were abusing it like crazy. But yeah, if you've got a data source which only changes once a day, that's only 24 deploys a month. You know, it's not a big deal. So I have, for some of my projects, like the PGE outages stuff, because that's a database that changes every few minutes, I tend to run those on traditional hosting providers with cron jobs that write to a database on disk. But yeah, if you've got data that changes less often than that, I think there's no harm at all in just deploying a brand new version every time you have an update to the data. Okay. I think I've answered all of the questions in the document. I'm going to pair it with it and to finish off.
Thank you, Simon. That was fantastic. A really great tour of Dataset and where Dataset can go and the kind of impact it can have. And I am going to abuse my privilege and ask one final question. Right now, this is clearly at a stage that demonstrates the possibility, sort of the power of the approach that Dataset espouses of pulling in data, having a static data set, and then exposing an interface for working with that data. And looking at this, I can see a future where I reclaim control over the 49 silos of my personal data. What does that future look like? You know, if I wave a magic wand and say, okay, now it's easy enough for the quote unquote non-super nerds to do this sort of thing. What do you think that future looks like when it comes to sort of our personal data? Whether or not through Dataset or through other tools, where are we going with this?
So I think my personal, like my dream state is anyone can install the Dogsheep app on their phone. They can like click some buttons in it to authenticate against different providers, start getting that data coming in, and then they can also like occasionally like do, well, you know, ideally that would give them, and to be honest, like Apple Health Kit is sort of hinting in this direction. Apple Health Kit integrates with your doctor's like online database for your health data, but why can't this exist for all of your other data as well? The APIs are there, the exports are there, the legal framework is there thanks to things like the GDPR. What's missing is the software that is easy enough for regular people to use that they can start pulling that stuff in. I'd love to get to a point with, say, with Dogsheep, where other people are using it to the point that they're building extra sort of plugins and features for it. Like imagine if I found a cool SQL query that figured out my heart rate over time compared to what I'd been reading on Twitter. And if I could bundle that as a SQL query and send it to you, and you could run that query against your personal data as well. I think I hinted at that with the thing that tells me what color my eyes are by running against my genome. I love the idea of this sort of homespun, here are queries that you can run, which will tell you something interesting, but I don't need access to your database. I'm just sharing the queries and the sort of visualization tools and maybe little JavaScript visualization plugins and so forth. So I think it feels to me like this could be a massively exciting open source ecosystem of homebrew personal analytics. Like you can find the simplest possible way for people to muck around, find something interesting, and then share it with other people. Maybe that comes down to like a sort of plugin marketplace, or I don't know quite what shape that could take, but it feels like something that really fits in with the ethos of open source.
Yeah, you know, if we think about all of these piles of data, what you're talking about is not just a sharing of like, oh, here's a plugin. It's here's a means. I've figured out how to extract some meaning from this data for myself, and I'd like to share that meaning tool with you. And so it's a marketplace of meaning, which is obviously one layer above the raw data, which is what we all struggle to sort of get at. So fascinating. Simon, thank you so much for coming and sharing your work with us and sharing your time with us. And hopefully we can have you back at some point to tell us about new and exciting developments in the space.
Awesome. Thanks a lot. And I'll update our Google Doc with a whole bunch of extra stuff. So if people keep an eye on the Google Doc, it'll turn into a handout later on.
Okay, fantastic. Thank you.
Thanks for having me.